Hello students! So this video here is the standard form of quadratic functions, the second one. This video is going to be a little bit different because there's not a discussion board attached to this assignment and this lesson here. This video is specifically for you so that you can see exactly how the assignments that I've assigned for you today, October 7th for you, okay? So you can see exactly how those assignments are or exactly how I'm going to ask you to show your work for those assignments and to do them. You guys may have to excuse me if my energy seems a little low. Because I've just had the wonderful pleasure of starting this video over again. And I was pretty much very, very close to being done. But anyway, we're not going to dwell on that. So, one of the first assignments that you've got on your Delta Math, or one of the first components in the Delta Math part of this assignment is the axis of symmetry and vertex with formula. And so on that, you'll be asked to either find the axis of symmetry or you'll be asked to find the vertex. But again, for this particular example, and this is not the same as any of the examples or any of the problems that you will probably have. Because I made this up. So anyway, so let's look here. It may say something like find the axis of symmetry, and of course it probably won't also ask you to find the vertex too, but again, this is my example. So find the axis of symmetry and the vertex of y equals negative x squared minus 8x plus 13. So again, guys, to find the axis of symmetry, we need to use the formula x equals negative b divided by 2a. Again, folks, remember that first we got to identify what our a value is and technically what our b value is. Really, you don't even have to identify what the c value is here. But again, the a value here is negative 1, and the b value is negative 8. Because again, remember this is in standard form, which is that form ax squared plus bx plus c. Again, we've identified a and b, and again we need to use that formula. And we need to write out the equation for that axis of symmetry. So again, that formula x equals negative b over 2a. And so again, remember that negative b is not negative b. That is the opposite of whatever b is. So again, you take the opposite of, meaning that you multiply it times negative 1, because technically the coefficient there is negative 1. Okay, the coefficient for that b is negative 1. So again, you use the opposite sign or you multiply it times negative 1. So we've got the opposite sign of negative 8 divided by 2 times a. And so when we do the opposite of our b value, that's going to wind up being positive 8. And then when we multiply the value of a times 2, that gives us negative 2. So we've got 8 divided by negative 2, which gives us negative 4. And again, guys, if you do not write out this axis of symmetry, and by the way, I've got it shorthanded, I got it abbreviated as AOS. If you do not write this axis of symmetry as an equation, you are going to be wrong. Okay? So when I say you need to show your work for this assignment, this is what I'm looking for. If it's asking you to find your axis of symmetry, you need to show this work here. And again, you've got to write your axis of symmetry as an equation, because again, for a quadratic function, the axis of symmetry is going to be a vertical line. And again, in order for you to tell what that axis of symmetry is, you need to write it as an equation of a vertical line, which means that it's going to be written in this form: x equals some number. Okay? All right, so that's that part. And again, for my example, I'm also asking you to find the vertex. But again, on Delta Math, it may be a case where it's just asking you to find the vertex. But again, folks, whether you're finding the axis of symmetry or the vertex, you're going to use that same formula. That same formula, negative b over 2a. And so again, if you were on Delta Math and you had a problem where it was asking you to find the vertex of a problem like what you see here, then we would need to, again, use that formula, and you would need to show your work showing how you're plugging in the a value and the b value, and you were able to get the -4. Now, guys, if you're asked to find the vertex, you're going to have to write it as an ordered pair, because the vertex, again, is that point in the middle of your parabola, usually either at the bottom or at the top of the parabola, depending on the shape of your parabola. If it's a U shape that's opening up, or if it's a U shape that's opening down. But again, the vertex, if we're asked to find that, you're going to have to write that as an ordered pair. So, excuse me. Yeah, I've already got all this written. Yeah, because this is not the first time that I'm doing this particular video. Anyway, again, so you're going to have to find that x value of the vertex, again, by using that same formula, that negative b over 2a. Show your work for that. And again, once you've got that x value for your vertex, then you're going to need to find the y value. And so, in other words, you're going to need to evaluate the function, and you're going to need to find that output value for the x value, or for the input value that we've found here. So you're going to need to plug in the x value. In this particular example, that's -4. Excuse me. You're going to need to plug in the x value, -4. And you're going to need to find your y value. So when we do that, we replace each x in this equation. You replace each x with that input value, -4. And so we've got negative, because it was already a negative symbol there, and we replace x, and we put in parentheses -4 squared minus 8 times -4 plus 13. So when we do that, again, either you can put this in your calculator the exact way that I've got it written, using the parentheses with the negative and then parentheses and all that. Or again, if you're not doing it with the calculator, make sure that you're using your order of operations and you're doing this correctly. Make sure you're simplifying this correctly. So again, order of operations, remember that's PEMDAS. Parentheses, exponents, multiplying, dividing, adding, subtracting, in that order, right? That you're doing it the right way. So again, if we were going to use the right order of operations here, we would do the exponent first, and there's only one exponent. So we need to simplify this -4 squared. And so remember, this -4 squared, that means that we're multiplying -4 times itself, or we're squaring -4. When we square -4, we get positive 16. So that's positive 16, and we still got the negative sign in front of it, in front there, because it was a negative sign in front of that. So we still got the negative 16. All right, so our exponent part is handled. Now we need to multiply, doing that order of operations. So let's multiply the -8 times -4. When you do that, you wind up getting positive 32. All right, So now that we've done the multiplying part, the only thing that's left, really, because there's no dividing here, the only thing that's left is adding and subtracting. And so for this particular part here, we're just adding, okay? And so when you do the 32 plus 13, that gives you 45. And then when you put in that negative 16 plus 45 gives you 29. So the y value, when we plug in this x value of negative 4, the y value is 29. Again, folks, you're going to you have to write the vertex as an ordered pair. Okay? If you don't write the vertex as an ordered pair, you're wrong. And you have to write the axis of symmetry as an equation. For a quadratic function, it's going to be the equation of a vertical line, which is in the form of x equals some number. And we've already told you what formula to use to figure out what that x value is. Okay? All right, so that's that. Look at another example. Again, it's already written out because this ain't my first time making this video. Okay? All right, so I apologize if you wanted me to write something out. Oh well. Sorry. It's already written out for you. All right, so let's say that we were finding the axis of symmetry and the vertex of f of x equals x squared minus 5x plus 1. Again, folks, sometimes they may not write it as y equals. They may write it as f of x equals. But again, we need to go ahead on and calculate what the axis of symmetry is using that formula of negative b over 2a. And so, again, if you go ahead on and identify your a value and your b value, that is going to be, the a value is 1 and the b value is negative 5. And so if we plug in the b value and we plug in the a value, that's going to be the opposite of negative 5 and 2 times 1 at the bottom. And so that's going to be 5 over 2. And so we leave that there. I'm sorry. Yeah, it's been a long day. Yeah. So again, you've got to write this axis of symmetry as an equation, or as the equation of, and we write it in the form of x equals that. You can either write it as a fraction or you can write it as a decimal. That's up to you, folks. So again, that was the axis of symmetry. The same example this is my example, where I'm also asking you to find the vertex as well. And again, this is how I'm going to ask you to show your work for this particular set of problems on Delta Math, where you're asked to find the axis of symmetry and vertex. So again, so if you were asked to find the vertex for this second example here, again, vertex has that same formula, or the x value of the vertex has that same formula of negative b over 2a. And so, again, it's that same x value. Yeah. I'm not even going to try to cut out my yawns here out of this video. I'm not even going to try to edit that. Again, it's been a long day. Yeah, sorry. But anyways, yeah, the vertex is going to have the same x value as the axis of symmetry, and then you're going to have to again find that y value. Again, folks, once you got that x value of the vertex using that formula, you're going to find the y value. And since this was written as, it was written in a function notation, where it was written as f of x, then we need to make sure that we evaluate this function. So I've got it written in function notation still, where we're asked to find the y value. So in other words, we're asked to find f of f of that input value, f of the x value that we need to do there, f of 5/2 or f of 2.5. And again, folks, remember that means that we are finding the y value at this particular x value. So again, when we do that, we've got to replace each x value in that equation with the input value. So when we do that, and again, guys, I love fractions, so I've written this out as fractions. Again, when we square 5/2, we wind up getting 25 over 4. When we multiply -5 times 5/2, we get -25 over 2. And then, of course, the plus 1 is just the plus 1. Again, for those people who might not be fraction type of people, and again, they're the exact same numbers, whether you got it written as a fraction or whether you got it written as a decimal. It doesn't matter. But again, as decimals, that would be 6.25 minus 12.5 plus 1. And when we simplify that, again, we'd wind up getting, either as a fraction, it would be simplified as -21 over 4. But again, as a decimal, it would be simplified as -5.25. And again, that's the y value when x equals 5/2 or when x equals 2.5. So again, folks, remember with the vertex, you have got to write it as an ordered pair. And if you don't, it's going to be wrong. And remember, for axis symmetry, you've got to write that as the equation of a line. And again, for quadratics, that's going to be written as x equals some number. All right, so for the next part that you'll have to do in delta math is finding a maximum or minimum values. And again, folks, remember that minimum value is talking about the function value for the function value or the y value at a minimum. So this particular example, and again, it's my example, so I'm asking you to find the maximum and the maximum value. And again, I'm reiterating that there's a difference between a maximum and a maximum value. Okay? Excuse me. So again, a maximum is where we're going to find that highest ordered pair, or that highest point, or in other words, we're talking about a relative maximum. It's the highest point compared to all of the points that are nearby it. But again, if you're asked to use technology, again, for this particular problem set on Delta Math that I've assigned to you, then you don't need to show your work for this particular set. But again, the easiest type of technology for you guys to use is going to be Desmos. Okay, and so if we can get this to do that the right way. Okay, so guys, this particular example here was negative 2.1 x squared. Sorry, it was y equals negative 2.1 x squared plus 5.7 x plus 21. And so if we're doing this in Delta Math and we're asked to find the maximum and find the maximum value, again, it's as simple as again, you may have to zoom out or you may have to zoom in, but again, that relative maximum is going to be that highest point there. And again, I'm let me see, it usually, there we go, see? All right, so when you type that in immediately on Desmos graph, they'll have certain points that are kind of sort of visible to the eye. And again, guys, you're not going to be looking at all of these points. Again, these are certain key features and critical points for this quadratic function, but you're not going to be looking at all of these. Again, you need to know exactly what you're looking for. They didn't ask you to find x-intercepts, which is these. They didn't ask you to find the y-intercepts, which is this one here. They asked you to find the maximum. And so the relative maximum is this coordinate point right here, 1.357 for the x component of that ordered pair and 24.868 for the y component. And so that is the maximum, this ordered pair, and you've got to write it as an ordered pair. So again, the maximum is that ordered pair, 1.357. And again, guys, when you're dealing with a relative maximum or relative minimum, that is going to be the exact same thing as a vertex. So again, whatever your relative maximum is or that relative minimum is going to be for a quadratic function, is going to be the same thing as the vertex. So again, that was that. And then, folks, again, I'm asking you to find the maximum and to find the maximum value. But again, on Delta Math, they'll only ask you to find the maximum value. And remember, folks, when you see here, the maximum value is going to be the y value of the maximum. So once you've identified the maximum, to find the maximum value, all you got to do is pretty much state what the y value of that maximum is. Okay? That shouldn't be hard. Now, on Khan Academy, sorry, not Khan Academy, sorry. This assignment here is on Delta Math. On Delta Math, they will ask you to round to the nearest hundredth. And so, guys, remember the hundredths place is this part here that is, or this digit that is 2 spaces after the decimal. And so the hundredths place is where the 6 is. But again, guys, you'll either have to leave it, when you round, you'll either have to leave it as a 6 or you'll have to round up based on the number that comes after that. Again, remember, folks, that if that number that comes after the hundredths place, if the number that comes after that is a 5 or higher, then you're going to have to round up. But if it was a 4 or lower, then you just leave it as a 6. But again, clearly here, guys, because that number that came after that was an 8, we round up here. And so if this was an example on Delta Math and you were asked to find the maximum value, then you would write this as 25.27. Okay? And it's based off of doing it there, okay, on Desmos graph. All right, so the next thing on Delta Math, the next little component of that assignment on Delta Math is finding roots or finding the vertex, or finding roots and finding the vertex with technology. Guys, you should be familiar already with what a vertex is. The word root, I've not used that word with you so far. But again, we have talked about roots before. I just didn't use that particular word to describe them. When we were looking at solutions for quadratic functions, or real solutions for quadratic functions, or real solutions for polynomial functions, because we know that quadratic is a type of polynomial function. But again, roots, again, I've used the word zeros in one of those videos where we were solving quadratic functions. But again, roots is the same thing as 0. It's the same thing as your x-intercepts. And it's the same thing as your real solutions. Okay? So when you're asked to find the roots here, Again, some particular problems may ask you to find zeros, but when you're asked to find the roots, we're asking you to find the x-intercepts. Again, if you're asked to find the real solutions of quadratics, all of these are interchangeable. All of these terms, roots, zeros, x-intercepts, real solutions so they're interchangeable. But again, we're talking about the x-intercepts. So, for this example, and this is my example that I made up, okay? For this example here, find the roots and vertex of c of x equals 3x squared plus 21x minus 106. So, again, the easiest way for us to do this with technology is to use Desmos graphing calculator. Yeah, I'm going to turn that graph off. Actually, I'm just going to erase that one. There we go. What did I say? 321 negative 106. Okay. 3x squared, I said x squared now. Plus 21 minus 106. That ain't 106. Let's try that again. 106. Nope, that ain't 106 neither. Okay, 106. All right, and minus 21x. Let me make sure that's right. (321 negative 106). 321 negative 106. Okay. All right. So again, if we're asked to find the roots and the vertex, again, guys, I'm just going to zoom this out. I'm going to zoom it out right now where we can see the vertex and where we can see the roots, which are, remember, roots are the x-intercepts. So again, folks, when you type this in on Delta Math, they'll have certain points already sort of kind of visible if you look closely. But again, you need to know which points you're focusing on, which points you're looking at. You should be able to recognize where the vertex is, even if those points aren't already, even if they're not already like showing up. You should know that your vertex is that point there, and even if this is not showing up there, you can still click there, and it'll highlight the exact point that it is. So we've got the vertex here. Again, they're not asking us to find the y-intercept, so we don't have to do anything with this because that's the y-intercept. But again, they are asking us to find the roots as well. So again, the roots are these two. In other words, are your x-intercepts. Zoom in on that. So we got your vertex there. Okay. Technical difficulties here. Let's see how long it's going to do that. Okay, so again, folks, for this particular example, we've got our vertex, our two x-intercepts, and this, again, the vertex is negative 3.5, negative 142.75 for this example, and the roots, which are the two x-intercepts, if there are any real solutions, or if there are x-intercepts, because not not all quadratic functions have x-intercepts. And the quadratic functions that don't have any x-intercepts, that means that they don't have, that the quadratic function doesn't have any real solutions. And again, we've talked about imaginary solutions. So again, not every quadratic function has real solutions, or has roots, or x-intercepts, or zeros. All right, the last thing that you are going to do is an assignment in Khan Academy. And for that assignment in Khan Academy, you are asked to graph. A quadratic function, and I'm asking that you guys show your work for doing that. And I'm going to show you exactly how you need to. I'm not saying that you can't use any technology or anything like that, but I'm going to show you exactly how I want you to show your work for this, for graphing this quadratic function in standard form. So, guys, this was right about the place where I was when my first video unfortunately malfunctioned, and I had to start over again. Yep, we're on our last little leg here, on our last stretch. All right, so again, folks, if you are asked to find the and it won't be finding the roots or finding that, it's going to be graphing. For this assignment, graphing quadratics in standard form in Khan Academy, let's say that we had something like graph y equals, and we're just gonna pick something, anything that we can put up here. I'm gonna pick something that's not too difficult. Nope, I don't want to choose that one. Let's do, yep, that ought to work. And then, yep, that ought to do. Actually, let's make that plus. Or, yeah. But that depends, so. Actually, but that's okay. All right. Sorry about that long pause, folks. I just want to make sure that that's going to look the way that I want it to look, and it is. All right. So if we're asked to graph that, the way that I'm going to want you to show your work for this is I'm going to want you to write out your table of values. I'm going to want you to write out a table of values where you're going to put in that table five different ordered pairs, or five different coordinate points. Table of values with 5 points. Okay. Five points. And I'm going to need for I'm going to need for you to put the vertex in the middle. Let the vertex be that point that is in the middle. When you do this. I have 5 points. When you show your work for this, put the vertex in the middle. Okay, really? And try to show other points close to the vertex that are sort of kind of symmetric around the vertex. So if the vertex is going to be like that one point in the middle, then there should be other points. There should be other points on both sides of the vertex that should be symmetric to each other. So again, and I'm about to show you, of course. So let's look at this particular graph on Desmos graphing calculator. All right, and so we'll show you again. You can use the graphing technologies, graphing calculator or Desmos, to do this. But again, the work that I want you to show for this particular example, please understand me. The work that I want you to show is where you are going to make a table of values with 5 points, put the vertex in the middle, and let me show you exactly how you're going to do that. Okay, what was that equation? Negative or was it positive? Positive, negative. 112.7. 112.7. It was negative, I think. If it wasn't, I could change it. 112.7. What is that? That don't look right. That's better. 112.7. Yeah. Plus 7. Okay. So we've got this this function here. We've got the graph of it where you can see that. All right, so 5 points that I want you to do. I'm going to zoom in. I'm going to zoom in. I'm going to zoom in. I'm going to zoom all the way in on that. And I'm going to zoom in around the vertex, okay? So where we can see these points around the vertex. So notice how right now, guys, you really don't see any points there, right? But you should know which point is the vertex. Click on it. Boom. There it is. There's your vertex. 643 for this particular example that I'm using right now. 643. So what am I saying? When you show your work for this, even though you can use something like Desmos graphing calculator, again, I want you to put in table. I want you to write these ordered pairs in the table. 643. That was the vertex. That's the part that I want. That's the one that I want you to put in the middle, the vertex. Now, around that vertex, you should be able to identify certain points, and I'm talking about like whole number points. I'm not talking about like numbers that are decimals. Like you see these decimal numbers here, all these decimal numbers. I'm not talking about those decimals. I'm talking about the ones where they're whole numbers. You get what I'm saying, right? I hope so. I really hope so. All right. So that's your vertex, 643. I'm talking about whole numbers, like right here. And I don't even know that they're even going to allow me to even put that up there. But guys, if you hold it, okay, you can see what that is, right? That is 742. Now I'm literally holding my finger on the clicker because when I let it go, it won't show it anymore. All right. For that point, so I gotta hold my hand down on the clicker to actually see what this point is, to actually see it. So that's 742. I'm going to write that in my table. 7 is on the right side of 6. And there should be a point on the other side of that is symmetric to it as well. I wonder if it will. That was 742. I've never tried this before. Hey! Haha! It's actually showing it. I've never tried that before. So you can see this is my first time. I'm learning that right now. So you can actually, again, once you realize that it's that point 742, if you want to actually see it, you can put that as a point up there. See, I didn't even know you could do that. I'm learning. All right, and this point is clearly 542. All right, so I'm gonna put that over here, 542. Oh, that ain't 42. Let's try that again. 542. Okay. All right. So you see how those 2 points that I just put up there are symmetric. Okay, one of them's on the right side of it, the other one's on the left side of it, but they're kind of symmetric around that. So this one, that one was 542. Again, folks, you're going to put your vertex in the middle, and you're going to start filling in around that vertex those certain points that are very, very close to it, but that are around it. All right, let's see the next one. Let me kind of trace this on down here. Let's trace it to the next whole number. That looks like 439. Let's see if we can actually get it to say that. Aha! 439. You see that? Look at that. Great. Awesome. Brilliant. 439. Now, this part might be easier if you have like a TI graphing calculator, because you guys should know how to view a table of values on the TI graphing calculator. Yes, right. So again, but again, it's not complicated to do it with this, but again, all right. So that's that point, and then that last point there is 8. Is 839. And I'm putting these points up here where you can actually see them, so you can see exactly which points around that vertex. And so you can see how these points are that I'm putting here are these points that have the whole numbers. All right. If we had to do more than 5 points, then the next one on the left side would be 334. The next one on the right side would be 934. All right. But anyway, we can stop here with these 5 points for this particular example. Okay. That was 439 over here, and 839 over here. All right. So we've got 5 points, and we've got the. Sometimes it'll be the closest 5 points to that, but guys, honestly, if you, because again, I don't really expect you guys to put any points up there that are decimals. So again, you should be able to identify what those points, the closest points to it that are whole numbers, where the x value and the y value are both whole numbers. But yeah, all right. And so once you do that, That will be you showing the work for me, okay? Just writing down that table of values for that particular graph. Now, on Khan Academy, what you're going to have to do is, let's go to that Khan Academy so I can show you. Now, of course, guys, this is not the same example that I've just shown you. So, again, I'm just going to show you what you would have to do on Khan Academy. So you can see here on Khan Academy where it shows you 2 points. So you're going to have 2 points here, and you're going to have to start off, guys, by clicking and dragging wherever the vertex is. You're going to have to put the vertex in the right place. So you see what I'm doing? I'm holding this, and I've clicked it, but I'm holding it, and I'm dragging this. So you're going to have to drag this vertex to wherever it is supposed to be. Let me do that again, in case you're not seeing what I'm doing. Click, hold, drag if you're on a computer. And nobody should have any issues with dragging it on a cell phone. Especially if you are doing it with the desktop version of whatever your internet browser is on your phone. You shouldn't have any troubles, not that I'm aware of. And don't quote me on that, but again, it should be easier if you're doing it on your phone. It should be easier for you to do it if it's in a desktop version of your internet browser. All right, so again, you're going to have to drag that vertex to where it's supposed to be. All right, now I just so happen to know that for this one, the vertex would be it would be at the x value of +1. No, it wouldn't. Right about you, Ray. Nope, it sure wouldn't be. Nope. All right, so we're not gonna guess at that right now. Again, if I had worked that out and actually done the negative b over 2a, then of course I can tell you what the x value of the vertex is, but I'm not about to do that because I've shown you how to find the x value for the vertex. But again, that's not what I'm asking you to do here. So again, the first thing you're going to have to do is you're going to have to drag that vertex to where it's supposed to be. And again, if they showed you know all the way to 643, then I'd actually drag that graph for my example. I would drag the vertex to where it is here, to 643. Clearly, right? So guys, once you have the vertex dragged to wherever the correct place for the vertex is, all you need to do from there is just drag this other point. Just one other point. Just drag it to any of those other 5 points. So again, drag it to any of the other 5 points, any of the other 4 points that I've asked you to put in that table of values. So again, if I had just one other point, just one other point on that graph. So once you've got the vertex where it needs to be, just drag this other point to any correct place. And again, guys, the work for me is done when you got this. Well, the showing the work is done for me when you've shown me this table of values with the vertex in the middle and 4 other points surrounding that vertex. But again, on Khan Academy, you will have to drag your vertex to where it's supposed to be, and you will have to drag one other point to where it is supposed to be. One other point, and you should already have the vertex and at least one other point if you've done what I've asked you to do and shown your work by putting this table of values with those 5 points. So I hope that this video has been helpful to you guys. Again, I just wanted to make this for you, my students, who I will either be seeing in the classroom or remotely, where I'm showing you what it is that your assignments will look like, and where I'm showing you, again, how I want you to show your work for these particular problems. Yeah. And so again, if you read all the instructions for the assignment, guys, I'm only asking you to show work for those parts where it is not asking you for the parts where it is not necessarily where it doesn't state like with the technology, or I'm only asking you to show your work for that first assignment in Delta Math, and I'm asking you to show your work for that assignment in Khan Academy. So again, for this assignment in Delta Math, where it says find the axis of symmetry or find the vertex with the formula, that's one where I'm asking you to show your work. And the other one where I'm asking you to show your work is the Khan Academy assignment that we just looked at, where it's asking you to graph this quadratic function. Okay? So again, I do hope that this video has been helpful to you in some kind of way. If nothing else, helping you to figure out how exactly you're going to do these assignments. Okay? So again, that's it, folks. Good night.